Welcome to this channel. In this tutorial, we will understand, design and simulate the voltage divider rule circuit using Multisim tool. Before going into this tutorial, I request you to like, share and subscribe to my channel below. Now, let the two resistors R1 and R2 are connected in series to a voltage source V of S. Now, the equivalent resistance of this particular circuit will be R1 plus R2. According to Ohm's law, the current through the mesh is given by I equal to V of S divided by R1 plus R2, and the voltage V1 across the first resistor is given by V of 1 is equal to R of 1 into I, which is equal to R of 1 into V of S divided by R1 plus R2, and the voltage V2 across the second resistor R2 is given by V of 2 is equal to R of 2 into I, which is equal to R2 into V of S divided by R1 plus R2. Thus, voltage source, that is V of S, is equal to V1 plus V2. When two resistors are connected in series to a voltage source with voltage Vs volts, the total voltage is divided between V1 and V2. This is referred to as the voltage divider rule. Now we will design and analyze the following circuit. Now click on source and select the power source. Select the DC power source and place this particular DC power source on the schematic window. Now click on basic and we have to select various resistor for this particular design. Now in the components section, search for 2 kilo ohm resistor and place this particular resistor on the schematic window. Next, we have to search for 3 kilo ohm resistor and place this particular resistor on the schematic window. So similarly, we have to place various other resistor in this schematic or in this particular design. Now again place 2 kilo ohm resistor, and similarly we have to place a 6 kilo ohm resistor, and in this particular design we have to place a 3.4 kilo ohm resistor and a 6.9 kilo ohm resistor. Now let us connect the resistor R6 to R5 and connect the resistor R5 to R6. Connect the resistor R3 to R5 and R4 to R6. Connect the resistor R3 to R4 and from resistor R2 to R3. Connect the resistor R1 to R4 and from resistor R2 and R1 to the voltage source V1. Now connect the voltage source V1 to resistor R5 and R6. Now click on source and select the group as source and click on ground. Place this ground connection on the schematic window. Now click on simulate and click on instruments and select multimeter. Place this multimeter across the resistor R1, and similarly we have to place the multimeter across the resistor R4 and also across the resistor R6. Now connect this particular multimeter across the resistor R1. Connect the second multimeter across the resistor R4 and connect the multimeter, that is the third multimeter, across the resistor R6. Now double click on voltage source V1 and define the voltage as 10 volt and click OK. Now run this particular simulation. Now double click on multimeter 1, multimeter 2 and multimeter 3. We can see the voltage across the resistor R1, R4 and R6. Now let us do the equivalent circuit of this design. Now we will determine the equivalent circuit. Resistance R1 and R2 are in parallel, R3 and R4 are in parallel, and R5 and R6 are in parallel. And we have calculated the equivalent resistance, which is 1.2 kilo ohm, 1.5 kilo ohm and 2.3 kilo ohm. Now click on source and select the DC power source. Place this particular DC power source on the schematic. Now select the group as basic and we have to place the equivalent resistance of 1.2 kilo ohm and 1.5 kilo ohm and 2.3 kilo ohm. So place these three resistors accordingly as shown in this particular tutorial. Now double click on resistor R7 and define the reference as RA. Similarly, define the reference as RB for resistor R8 and define the reference as RC for resistor number R9. Now click on source and place the ground connection on the schematic window. Now connect the voltage source V2 to the ground and connect the resistor RC to the ground. Now connect the resistor RB to RC and connect the resistor RB to RA and RA to the voltage source. Double click on voltage source. Define the value as 10 volt. Now click on simulate, click on instrument, select multimeter, place the multimeter across the resistor RA, across the resistor RB and across the resistor RC. Now connect the multimeter across the resistor RA, across the resistor RB and across the resistor RC. Now, the voltage VA across the resistor RA is calculated and it is around 2.395 volt. The voltage across VB is equal to 2.994 volts and voltage across VC is equal to 4.611 volt, and when we combine this together we get the source voltage value V2, which is 10 volt. Now run this particular simulation, you can see the voltage across the multimeter, and this voltage value matches with the theoretical value what we had calculated. Thank you for watching this tutorial. I hope this has helped your learning purpose. I request you to like, share and subscribe my channel below.